Hello, welcome to the Introduction to Maya Customization class. I'm super excited to be here to introduce you how you can customize and extend Maya's capabilities using the Maya API. So please follow along as I introduce you to this topic and show you how you can get started by building your own plugin. And at the end of this class, I hope you can gain a better understanding of the Maya API and gain some confidence to build your own plugin. So my name is Lan Hong. I'm a developer advocate and part of the M&E DevTech team here at Autodesk. I primarily support ADN members using the Maya API to build their plugins. I've been with Autodesk for 2 years, started in 2018 after finishing my Bachelor's of Computer Science from UC Davis. So how do you actually customize Maya? There are so many ways actually, and before I jump into the API, let me show you a few ways how you can customize Maya using just the interface. First, you can customize the look and feel of the user interface. You can drag around panels and dock them anywhere you like. And once you're done changing the layout, you can actually save it as a workspace so you can come back to it later. Or if you're feeling really fancy, you can change the colors of the user interface using the colors settings. You can also customize the menu sets. And these are the menu items in the menu bar you see on the very top of Maya. You can edit those using the menu set editor, and from there you can add or remove menu items from the menu sets, or you can create your own menu set and choose the items that you want to display. Or you can customize the shelves. There's actually a custom tab on the shelves where you can add your own items. You can add tools, menu items, or even commands or scripts into your shelf. You can customize the shelf by using the shelf editor. From there, you can also customize the icons and names for your shelf item. And there's a ton more you can do, such as customizing the hotkeys, marking menu, and the hotbox. You can actually find a list of things that you can customize in the Maya documentation. Alright, so let's take it a little further. Let's talk about customizing Maya using programming. With programming, you can create new features and extend Maya's capabilities. For example, you can create custom plugins, scripts, or applications that can be used inside Maya. So one of the ways that you can customize Maya using programming is to write scripts. You can write scripts using Mel or Python. And scripts are comprised of mostly commands. Commands are pretty much actions to perform a task. And everything that you do in the Maya interface is invoking a Mel command. So knowing that fact, you can actually automate a lot of these tasks by taking these commands and putting them into a script. You can run scripts inside the script editor. Here I have an example here. It's a Python script where I created a sphere and a cube, and then I grouped them together. And then I can just run the script over and over again using just one click. Another way to customize Maya is to build your own plugins. Plugins are just extensions or add-ons inside of Maya. You can build plugins using C++ or Python. And with plugins, you can create your own tools and features that fits inside of Maya. For example, you can create your own commands or your nodes, such as shaders, manipulators, locators, etc. And Maya actually comes with pre-built plugins available for you to use immediately. But before you can use any plugins, they must be loaded. And you can do that using the plugin manager or using a command. There are a couple of types of plugins: command plugins and dependency graph plugins. Command plugins defines a new command in Maya. And these commands can be invoked just like any other command or added to a script. A dependency graph plugin is essentially a new node in Maya. And this node can seamlessly integrate inside of the dependency graph and make connections to other nodes in Maya. So what are the benefits of customization? First, we can automate repetitive and common tasks. So remember, everything done in the Maya interface is just a command. And when you write scripts to do the same things over and over again, you can actually save a lot of time. And by building new tools and features, you can streamline your workflows. So you can create nodes or commands to increase your efficiency. And just by being able to customize, you can increase your productivity for yourself and for others. There are 3 programming languages that Maya uses: Mel, C++, and Python. Mel is a scripting language built for Maya use only. You can execute commands or write scripts using Mel, and everything you do inside the Maya interface invokes a Mel command. C++ is actually a pretty popular language in the industry. In Maya, it's used for plugin development, and many people will actually choose to use C++ to develop their plugins. Maya's core and API is actually written in C++ as well. And since C++ is a lower level language, it needs to be compiled, but it gives really fast performance. And then we have Python. The benefit of learning Python is that you can do both. You can do both scripting and plugin development. But Python acts more as a wrapper. So Python commands wraps around Mel commands, and Python API wraps around C++ API. All right, so let's dive a little deeper and talk about the Maya API. What is the Maya API anyways? API stands for Application Programming Interface. It's a way for an application to access and interact with another application. So in order for a plugin to behave like a native Maya feature, it needs some way to access Maya's internal resources. And that's where the Maya API comes in. It provides access and the tools to manipulate internal objects inside of Maya. So Maya API is available in C++ and Python. Like I mentioned earlier, the Python API is just a wrapper around the C++ API. And C++ and Python APIs are not perfectly mapped. So you may find that some classes or functions are missing, but the majority of the Python API is complete. So Maya Python API. There are actually 2 versions of the Python API, 1.0 and 2.0. The 2.0 API has better performance and it's more Pythonic. And by Pythonic, it means that it follows the Python syntax and conventional guidelines set by the Python community. And between 1 and 2, most classes and function names are kept the same, so it could get a little confusing on which one you're using. For the 1.0, to import a Python module, you do import maya.openmaya. And for 2.0, you do import maya.api.openmaya. And you also have to define a new function called Maya use new API. This way Maya will know to pass in Python 2.0 objects. So Maya API basics. The Maya API consists of objects, function sets, proxies, wrappers, and iterators, which I won't mention too much about details here. Let's start with objects. So model objects are represented by mObject class. Model objects are just Maya's internal animation, modeling, rendering objects, as well as all the dependency graph nodes and their attributes. So each object has a specific type and it works together with function sets. Next is function sets. These are classes with mfn prefix. They manipulate objects of the same type, and they can also create mObjects, and the mObjects that are created using function sets, they acquire the function sets type. So in this example, we have mfn NURBS curve. That class is used to manipulate mObjects with a NURBS curve type. Proxies. Proxies are classes that starts with mpx. They define objects that Maya will be aware about. So that means all the plugins that you create, they must extend one of these proxy classes. So for example, when we create a new node plugin, it must extend mpx node class. Or if you're creating a custom command, it must extend mpx command class. Next we have wrappers. These are classes with an m prefix. And these are just everything else. They are simple objects that can be manipulated directly. So for example, m vectors, arrays, etc. The Maya Dev Kit, also known as an SDK. You can think of this as a toolbox that you use to create the plugins. The Maya Dev Kit are just tools and libraries that you need to customize and extend Maya. This includes C++ and Python APIs, as well as plugin samples for you to see. So you use the Dev Kit to create plugins, scripts, and applications. So make sure to download the Dev Kit from the Maya Developer Center, and make sure to choose the Dev Kit specific for your system, Maya version, and update number. This is because Maya's architecture is written in C++, so downloading the correct version will ensure binary compatibility. Python plugins are easy to port over, but C++ plugins will have to be recompiled with every new release and update. Inside the Dev Kit, you'll find a ton of plugin samples written in both Python and C++. And these are good starting points so you don't have to start writing your plugin from scratch. For Python plugin samples, plugins that start with a PY uses Python API 2.0, and all the others uses Python API 1.0. For C++ samples, C++ plugins must be compiled before using, and steps to compile are found in the developer's documentation. All right, so let's create a plugin. We will be creating a dependency graph node using the Python API 2.0. All right, so before we create your plugin, I want to give you some background on what a dependency graph is and what we are creating. So a dependency graph is just a network of nodes, and each node has a set of endpoints and output plugs. And plugs are just connection points. They're used to connect to other nodes. And the node's behavior is to do calculations on the inputs and give the result as output. So you can think of a node as a box. It can only see what is given to them and nothing else. So what are we creating? we are creating a dependency graph node. And this node will fit right into the dependency graph and behave just like any other Maya nodes. Our plugin, we are recreating the ArcLen node. This node is actually a C++ sample that you can find in the dev kit. And we are recreating this using the Python API 2.0. So this node will have one input, which is a NURBS curve, and one output, which is the length, and it's going to be a number. And what it's computing is the curve's arc length. All right, let's get set up. First, choose a text editor. I will be using Visual Studio Code, but you can choose anyone that you like. Second, download the dev kit and set up environment variables. You can make sure to follow the instructions in the developer documentation. You can extract the dev kit anywhere, but just to be sure, make sure the environment variables are set correctly. Next, register for a node ID block. This is a very important step because you want your plugin to not conflict with other nodes. Each node needs their own unique ID in order for it to load inside Maya. You can find the link to register in the Maya Developer Center, or you can click on that link there. When you register, you get a minimum of 64 IDs written out as a hexadecimal. Hexadecimal is just a 16-digit numbering system instead of a 10-digit. So it goes from 0 to 9, and then 10 to 15 is represented by A to F. All right, so let's create the plugin. I'll actually be demoing this a little later, but I just want to explain the steps now. So first, we're going to start off with a template. So copy the skeleton code from the developer documentation. The link is right there. So this way, we are not starting from scratch. We're going to modify it and add to it to build our plugin. Next, we're going to replace the node ID with one of our own. And then third, we're going to change the node name from my node to ArcLen node. And then next, we're going to modify the input and output attributes. So our input attribute will be called input curve, and our output attribute will be called output. And then finally, we're going to do the actual computation, which is to use the MFN NURBS curve class to get the arc length of the curve. So after we're done with the plugin, we're going to test it. So first, we're going to save the file in Maya plugin path. This is the environment variable that you set earlier, and it's going to make it easier for Maya to find our plugin. Next, we're going to open up Maya and load the plugin via the plugin manager or the load plugin command. Next, we're going to test the node by running the script in the script editor. And this script will basically create a new ArcLen node. It will create a NURBS circle, and then it's going to connect the circle to our node. And then we're going to print out the output on the script editor. Okay, demo time. Let me switch over and I'll show you how to create the plugin. First, I want to show you the Maya Developer Center. You can also get here using a shorter link. You can use the link autodesk.com/developmaya. It'll take you to the same page here. There are a ton of resources here, but I want to show you where the dev kits are located in. So they're located at the bottom here. So I already have a dev kit downloaded and my environment variables set up. Here is also, you'll find the Maya developer node ID block link here. And then you just start the registration process here. And all you have to do is enter in your company name, contact name, and your email address. And once you register, they'll send you your ID block via email. To create the plugin, we're going to start with a template. But let me show you how to get to the developer documentation page. You're going to go to the link autodesk.com/MESDKdocs. This will take you to the 2021 documentation page, but just scroll down to find 2020 documentation. Find Autodesk Maya and click View Online. Alright, so this is the main page. You can just simply bookmark this page for future access. Alright, so let's find the skeleton code that we will be using to create our plugin. It's located in Maya Python API, Maya Python plugin learning path, dependency graph plugin basics, and then dependency graph plugins. So here's the code that we'll be using as a starting point. Okay, so I just copied and pasted the skeleton code into my text editor. So let's get started coding. The first thing we want to do is change the node ID. The node ID is just a hexadecimal number. It's a 16-digit numbering system that goes from 0 to 9, and then 10 to 15 is represented by A to F. So I'm going to change this. The number that I got is 0, 0, 1, 3, 6, 3, 0, 0. Okay, that's my node ID number. Next, we're going to change the plugin node name. This is the name that Maya you use when creating the node. So I'm just going to change this to arc-len node. I'll also change the class definition name from my node to arc-len node as well. This can be pretty much any name that you want as long as it's intuitive to you and using it correctly. Alright, now that I changed the node name, I will modify the input and output attributes. So I'll change the variable names to input curve for the input, and then I'll change the output to be called output. I'll also change the data handle variable names, and I'll explain what these are in a little bit, but I'll call these input handle. I'll call the output handle. Okay. Next, let's change the long name. So these are the names that will actually show up inside of Maya. So I'll change this to be input curve. And then I'll change the output name to be called output. All right. The next thing I want to do is add in a typed attribute. Since our input attribute is a NURBS curve, we're going to use the MFN typed attribute to create a typed attribute. All right, so we're going to use this class, this function set class, to create our input curve. So I'm just going to replace numeric attribute function set with a typed. Okay. The output will keep the same because we're going to use the output is just a floating point number. So we're going to use the numeric attribute function set. Next thing we want to do is change the type. So currently it's set as a float, but we want to set it as a NURBS curve. I'm also going to delete the default value. The default value is actually optional, and a typed attribute, by default, the default value is going to be a null object. All right, so we're done modifying the input and output attributes. Let's do the actual computation. We do that in the compute function. So first thing we want to do is our input handle is reading our input as a float, but we want to read it as a NURBS curve. So we're going to use the method as NURBS curve transformed. All right, so this is going to read in a curve. I'm just going to change this variable to be called curve for readability. Then we're going to do the actual computation. So in order to get the curve length, we're going to use a function set, the MFN NURBS curve. I'm going to pass in the curve. The MFN NURBS curve class has a function called length that returns the arc length of the curve. All right, so that's going to return the length. And what we're going to do is just pass the result and set it as the output. All right, and that's all you need to do for this plugin. All right, so let's save our file before we test it. So let's save. Make sure you save your file in your Maya plugin path. This is where Maya is going to look for custom plugins. So my plugin path is this. Yours might be the same. You should have set it up when you were setting up your environment variables. So I'm going to name my file node and make sure you have the Pi extension. All right, now that that's saved, let's open up Maya. We can load the plugin in two ways. You can do so using the plugin manager. Once you refresh, you'll see it here. Or you can do so in the script editor by using the load plugin command. So in order to test this, I'm just going to run the script. It's going to create our node, create a NURB circle, and then we're going to connect the attributes, and we're going to print out the results in the script editor. So I ran that and got a result of 6.2. All right, so now that we created our plugin and tested it inside of Maya, let's go back to the code and just walk through it a little bit. So the first thing that we do is import our Python API modules. We do that at the very top. And since we are using the Python API 2.0, we are defining the Maya use new API function. Next, we have the plugin information. We have the plugin node name. This is the name that Maya uses when it creates the node. Next, we have the classify. Since we are using this node as a general utility node, we classify as utility/general. And then we have the node ID. This will help Maya distinguish you apart from the rest. And we actually don't need this anymore. So that's some basic information. Let's go down to initialize function, initialize plugin function, and uninitialize plugin function. The initialize plugin function is the entry point to our plugin. So when Maya loads our plugin, it calls this function. And what it does is registers our node by passing in some plugin information, as well as the node creator function, the node initializer function, and the node type. The uninitialized plugin function is called when Maya unloads our plugin. And all it does is deregisters the node. So after the initialize plugin function is called, Maya calls the node creator function. And what this does is creates an instance of our ArcLen node and returns that to Maya. And when that's done, it calls the node initializer function. This function defines the input and output attributes. So the first thing that we do is define the function set for a numeric attribute and the typed attribute. We are using this to create our attributes. So for our input, since our input is a curve, we are using the typed attribute function set to create the attribute. And using the create function, we are passing in the long name, the short name, and the attribute type. This long name and short name is what you're going to be seeing inside of Maya. And these attributes, you can set them as writable, storable, hidden, or others. Then after you set all of that, you're going to add the attribute back to the node. Right? And we do that to the same, we do that to the output attribute. And then after we do that, we set the attribute dependencies using the attribute effects class, the attribute effects method. And what this does is ensures that every time our input gets changed and our values become old, it makes sure that it recomputes our output. Okay, so let's go to our node definition. So our class ArcLen node extends a MPX node class. This makes sure that Maya recognizes this plugin as a node. At the top here, we defined our input and output. This will get replaced by the attributes that we added in the node initializer function earlier. The init function is a constructor, and this gets called every time an instance of ArcLen node gets called or created. And since this class extends npx node, it also calls the constructor for npx node as well. Now the bulk of the work is done in the compute method. So the compute method is called when a plug is dirty. So the dependency graph has uses a evaluation process where it marks an output plug as dirty if the output values are stale and needs to be recomputed. So compute method gets called with the dirty plug along with its data block. The data block contains data handles, and data handles lets you store and handle the actual values. So the input data handles allows you to read in the values, and the output data handles allows you to write out the data. So here we're going to use the input data handle to read in our NURBS curve. And we're going to do the computation on it using the NURBS curve function set and its length method. After we get the result, we're setting the output, the result as the output using the output data handle. And since our output is still marked as dirty, we need to use the output data handle to set it as clean. That's the only way to remove the dirty flag. And that is it for the walkthrough. So now that the demo is done, you can see how easy it is to get a plugin up and running inside of Maya using Python. So to help you continue this journey into the Maya plugin development, there are a ton of online resources available to you. First, we have the Maya Developer Center. This place is super important because it has all the tools that you need to develop your plugins, such as the dev kit download links, and also the link to register your node ID block. There are some learning materials and resources available here, such as code samples, blogs, white papers, and other links. Next, we have the Developer Help documentation page. This is the official page for the Maya API. It's the #1 place to learn, has a ton of information, has some code samples and tutorials as well. It also has links to the C++ and Python API references, and these reference pages is where you can look up classes and functions and how to use them. So yeah, you'll be using these pages very frequently. Next, we have the Programming Forum. The Programming Forum is a community area where you get support from your community members. You can share and contribute by posting or answering questions. You can also just ask questions or browse for solutions. Lastly, we have the Autodesk Developer Network, or ADN. So ADN is a developer program for customers using our technology to extend Autodesk products. We have a free membership called the ADN Open, and it's pretty much just resources available to the public. Or you can consider joining and upgrading to ADN Standard or Professional to get one-on-one API support. And by joining, you'll get licenses included with your membership. Thank you so much for tuning in. I am super excited that you made it this far. So I want you to try building a plugin yourself tonight and see how easy and effective it can be. I hope you can continue learning the My API. It'll be a long journey, but it'll be worth your time. Again, thank you very much.